Hello. As the title suggests, recruiters hate this one simple trick. And you know what it is? I don't know either because I haven't applied to any jobs. Why? Imposter syndrome. Um, Also, maybe I'm not qualified yet. Maybe I am. I don't know. And I'm just allergic to job applications. I see the form, I get an email, apply to this job. It scares me. It scares me. But hopefully one day we'll get over that fear together. And I was watching back end back end banter today. I don't know why I put the emphasis on the B there. Acento en la B. Uh, and really great podcast, not gonna lie. And the dude was like, "Oh, they were like, what's your one simple advice for you would give to people trying to get into DevOps?" So obviously applies to everyone. Hell no, I'm not gonna do DevOps. What the um. But the advice was basically just to start applying, because if you start applying, the worst they can say, I mean, obviously everyone's heard this, right? But sometimes you got to hear it 5 times a week for 4 years, maybe even more before it actually clicks. But anyways, uh, the worst they could say is no. And there's even a chance that you might get useful feedback to know what you need to improve to, get a position at not necessarily that company, but just be a more desirable candidate for a role you're looking into. Uh, so yeah, I don't think I can apply to jobs on live stream because I don't know how I would like block out all of my personal information. Hold on this. Okay. I don't know how I'd block out all my personal information, but that's something I need to be doing. So add that to the list of things. What am I drinking today? We straight up we coding not sober. We are coding drunk. We are coding inebriated, intoxicated, and just not okay, because that's the only way I'm going to get through logical problems like the ones on LeCoding and stuff. Just kidding, it's liquid death, obviously. So why am I stalling? I've been talking for 3 minutes and I've yet to even share my screen. It's because I'm going to reattempt top K frequent elements. Recruiters hate this one simple trick. It's being prepared to do a coding interview. Now, do I agree that this is the best solution for determining whether someone is, uh, job ready? Hold up, let me share my screen. Okay. Uh, who am I to say? I've never had a job. But there's several people who have, and they think it's not. But that's just the lay of the land right now. And if someone won't do it, then somebody else will, and for half the pay. So I got to get to it. Okay, again, failed at this one, got absolutely annihilated. I am going to slightly change my approach. I'm going to actually, have 30 minutes on the timer, and I'll finish out an idea if I really have it, but otherwise, I'm just going to watch the parts of the solution. Okay, I'm still iffy on this. I don't know if I should just watch the whole solution and then implement it and then retry the problem another time, or if I should, watch parts of the solution until I have enough information to make the solution. The latter is probably easier. I just want to make it a little easier for myself in the beginning because the mental friction I have for doing like, you know, coding problems like this is insane. Like, it's getting better, the more I do them and the more, dopamine gets released as I get a little green check, but it's still pretty difficult. Like my brain wants to resist doing this. Um, okay, with that being said, I think I'm gonna mute the timer too because last time it went off and it was so annoying. Timer, boom, muted. Wait, whoa, 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 whoa. Okay, I have code here. Honestly, just gonna clear it. I don't even want to look at what dumb. Yeah, what the hell? Other thing I'm gonna do is I don't want to start coding until I've written out exactly what I think my solution is. Additionally, there's probably exists some sort of like what's the word, process. Uh, yeah, I guess sort of like process where I'm sure like a list of questions you can ask yourself while like to make sure you approach every problem in a systematic way. I don't know. I'm gonna look for it like after today, so I can start doing that. But I am going to try to apply some sort of system to the solution, other than just sitting there being like, "Oh, well, maybe I can do this. Well, maybe I can do that. Oh, well, maybe I can't," and then going into rabbit holes and all that stuff. Wow, what happened to my timer? I haven't started it again though. 30 minutes and I'm done because after that, like you kind of just get sick of thinking so hard and not getting the solution. Uh, so hopefully I don't cave under pressure. And let's do this. Okay. So given an integer array nums and an integer k, return the k most frequent elements within the array. The test cases are generated such that the answer is always unique. Given an integer array nums and an integer k, return the k most frequent elements within the array. Sure. Okay. The test cases are generated such that the answer is always unique. So I guess that means I will never have why does that matter? That's my first question. Why does uniqueness matter? Cool. Maybe if I answer that, maybe it could provide some insight into how to solve this. So here's obviously the list of what seems to be integers that can be negative. I'm also going to write this down too, maybe like my observations. Nums can be negative, bounded by 1,000 on each side. Wonder why that is. Oh, no, it's what it's saying actually is the individual numbers in the list cannot exceed negative or positive 1,000. So the ints can't exceed this. Yes, I forgot whether the brackets meant inclusivity or exclusivity. Python doesn't care anyway, so why should I? Just kidding. I should, but whatever. Okay. Num's length has a crazy, I guess 10 to the fourth isn't that crazy, right? What is that? 100, 1,000, 10,000. I'm not sure if writing that down is really going to help me, but it does help me that I always know list will never be empty. So that is important to note. I don't need to have like a if empty case. And this is another important one. I'm actually going to have this as a question because it is a little more new. I think there's more information in solving this question. But why is K, why us? Why is K bounded by the number of distinct elements in input list? Okay. So if we look at this example, let's look at example 1 first. K equals 2, and that implies that we want the 2 most frequent elements within the array. If we look at this array, obviously duplicates are allowed in the array. And it seems like the actual integers 2 and 3, not the indices or anything, but the actual integers 2 and 3 are the most frequent ones because 2 occurs twice and 3 occurs 3 times. So we would output in a list 2 to 3. 2 comma 3. Here, has to do with this case, right? Where if we have 2 elements that are the same element, then K, this number K can at most be 1 because we can't ever match. So I guess I'm kind of saying the answer to this right now. Cannot find, for example, 2 most frequent elements from a list of 1 unique elements. Yeah. So that intuitively, that just makes sense. You can't find something that isn't there. That's deep. Think about it. Think about it. Okay, now stop thinking about it. Why does uniqueness matter? I don't know. We don't want to all be the same, I guess. Because I'm special? Not sure. That's what my mom told me. Anyways, to actually answer this question, I think this means that we could have 2 lists, right? So let me just write an example. I could have 2 lists. 1, 2, 1. Okay. This would output, if K equals 1, then this should output, then output equals the integer 1 because 1 occurs 2 times. Now say I have the list 2, 1, 1. The output is the same. And what this, it has to be the same. So what this means is that there are the order of the list says the answer is always unique. Wait. I'm not sure if this, what would happen if the answer was not always unique? This is trying to say that there's no ambiguity in the test cases. Why would there be? Oh, I think this is actually talking about something different. Because right. So this is cool. Maybe I can think about this. I'm gonna put it where maybe unnecessary thoughts go, which is above the class solution. Wow, wasted time there. Any percent, any percent, any percent K top K elements in list, I've lost optimal time with that inefficient tab and deletion. Anyways, I actually think what it's saying is that, say we have this array 2, 2, 3, 3, 4, 4, and K equals 2. It's basically saying that this type of input will never be a test case, because what are the two most frequent elements in this list? Well, I can't pick, right? Because I have three, all three unique elements in this list have the same frequency. So there's ambiguity in what I should return. Sorry. Apologies for the baby. The baby. And it's saying I don't have to worry about a test case like this. Although if I did, I'm sure it wouldn't necessarily matter, because I could just, you could do like some sort of tiebreaker where, like, okay, the elements with the greatest integer value, those are the ones you would return. But anyways, we don't have to worry about that. What else? This is important. You may return the output in any order. Okay. Output order is inconsequential. Okay, I think this is, so I'm glad I answered this question. This makes sense, but this is just telling me information about what kind of input I'm going to have, which I guess could be useful to clarify. This too, right? Nums can be negative ints. This will never be empty. That's kind of useful. Output orders doesn't really matter. Okay, I guess now we can sort of try to think for a solution. So first thing I want to think about is, like, what kind of data structures would be useful here to solve this problem, if any. Data structures or some sort of algorithm. So I tend to neglect sorting as an option, because I haven't done any sorting problems and I haven't done actual sorting for a while. So I kind of suck at it. So I don't think about it, but I'm actually going to think about it right now. Is sorting useful? Well, okay, if I were to have an input array and put it in sorted order, let's say ascending, that doesn't necessarily give me any additional information about, in any particular order, it doesn't necessarily give me any useful information about my output, especially because the order of the output doesn't matter. So I really think sorting doesn't help me in any particular way. So I'm gonna just say no. Could be wrong, but that's my take. I'm Diego Martinez, and that is my take. Oh, last name dropped. Oh well. Okay. Is a hash map useful? Let's think first of let's just say hash map, right? So keys, values. Well, certainly, I think yes, off the rip, because I'd be able to count each number, and I could make a dictionary of every unique element, and then how many times I see that element, right? And honestly, that seems like to be I'm not sure if it's the most efficient. It does seem to be a very straightforward solution, though. So Why? Because we can have a hash map where the keys are unique integers, and then the values are number frequency of unique integer occurrences. Okay. So where would my solution be in this hash map, this data structure I just created? My solution would be in the two largest values. So I would probably have to iterate, right? Because we could look for two options. So let's say this. Where is solution in this, or we could say desired output. Where is desired output information in this hash map? Well, I think the answer to that question is it would be in the k greatest values. Okay, so how would I extract that? How to extract info? The way I think I would do that, or a super fast way that comes to mind, would be to iterate through the keys. Fast in terms of simple, like it's the first thing that came to my mind. I'm not sure if this is the most efficient solution. Iterate through the keys, and that'd be interesting. I'd have to make k variables and then save the k most frequent ones. Oh, but here's where sorting is useful. Cap. I said no. Hopefully that didn't completely kill everyone's ears. Yes. So instead of iterating through the keys, here's what we could do. We could, even though sorting, we could sort the keys. Sort the keys in ascending order or descending, whatever, and then return. We'll say ascending order. No, I want to say descending, actually. Descending order, and then descending order. And then, by the way, this is an imitation of somebody with a retainer. Being very specific about that. Somebody with a retainer, imitation of somebody with a retainer. You know, like I had to wear one for a bit. Just kidding, I've never had braces. That's why I have vampire teeth. Okay, sort the keys in descending order, and then return k. Return the first k elements, because that would be the greatest values. And now let me think about something like, what would be the runtime of this solution? So I'd have to first create my dictionary, my hash map, right? So that's already, we got to end there for the hash map creation, because I have to iterate through the entire list. Then what else do we have? We have to sort the list of values. So that's, in the best case, is going to add a log n term, depending on our sorting algorithm. But for good ones, it's usually a log n. It's going to add a log n term. And then we're going to have to iterate through the sorted elements. Or no, actually, we return the first k elements. Does that involve some sort of traversal or something? I don't really know. Do I just drop an N there? Yeah, sure, because it says right here, when we're thinking worst case, it says right here that K can be equal to the number of distinct elements in the list nums. So in the worst case, K would just be equal to the length of the list. So in the worst case, we'd be uh, iterating through through all the list of all the values, and all those values would be 1. And oh wait, I see an issue. I see an issue. Wow, I see an issue. But I'm gonna add an N there first, just because the second N represents in the worst case that I'd be like I said, iterating through all the values. However, wow, so we're at like N squared log N, which isn't very good. Again, I don't think this is the most efficient solution, but we'll find out what the most efficient solution is later. I see an issue where I asked myself, where is the desired information? I said in the K greatest values. That's not true, because my values correspond to the frequency, and the desired output is actually the unique elements. So I have to make an extra step. It would be in the keys, I'm at another line here. In the keys corresponding to the K greatest values. Yeah. So I could do everything I've done so far, and I'd have the amount of times that the K greatest values appear in my list, but I wouldn't have the actual integers themselves. And to extract that, I'm trying to think if that would cause an issue. And I do kind of see one. The whole point of a hash map, I believe, is like you don't want to change your key values, because no two keys. Yeah, no two keys should give the same output, I believe. Could be wrong. I could look it up. I'm going to later. But yeah, I don't know. Like, I don't think I can change my keys. So, and you can't find, I'm not sure if you can find a key with a value. I guess I could look that up. Can you find key corresponding to value in a hash? The baby's crying in the back because he's scared of LeCode, and he knows he's never going to find a job in this economy. But he's actually excited. That's why he just yelled. To find all the keys that map to a certain value, we have to do another loop. Yeah, so there's not a straightforward way to do this. I mean, this is Java, but let me get key from value. Is there actually a method? That has to be like super slow. Maybe I'm tripping. I don't know. When I see text, I like automatically don't want to read it, but I should read it. Isn't this cool, this Spider-Man pointer thing? I have 8 minutes. I'm cooked. No, I ain't reading all that. Okay. Actually, fuck, I should. Get the key value by using list comprehension. What does this mean? Get the key by value. So, because it's yeah, okay, I know what that is, which is executed for each element along with the for loop to iterate over each element in the Python list to get the key from a value. So here I have my dictionary. The keys are these strings, geeks for geeks. The value is I for I in dictionary, sure, okay. Print key by value. Wait, what? How did it do that? Wait, what? Oh, it's using I for I. Oh, what? This is actually like oh, I guess that's what list comprehension means. Maybe I should click that. Oh, buddy. Okay, so this is literally like a for loop inside brackets. I'm no Python expert, so this is kind of crazy to me. This is blowing my mind. This is blowing my Gen Z mind right here. So for each element, what? Okay, so I guess this is my index value. So this is corresponding to this I here, and then it's saying for each I in my dictionary I created, if dictionary I is equal, okay, basically I have to iterate through the entire dictionary to find all the values that map to this key, which is not good because that's a whole nother time I'm iterating on top of what I already suggested. And now we're at like n cubed log n, which is insane. So there has to be a better way. And you know, it's actually a good question. I'm not even sure if two, oh, Mr. Killer Babies is on here. Check out his channel, guys. He's actually pro-choice. He's definitely a pro-choice kind of person. But not for the reason you might think. Damn. Can I reply to this? Maybe it is. I wouldn't know. My Pythonic brain isn't developed yet. What am I trying to do? 5 minutes. I'm caving under pressure. I'm like Steph Curry in the finals, except the most recent finals he was in. All this. Oh, right. I wanted to look up, can you even map? No, that makes sense. Two keys can map to the same value. Yes, that's fine. But one key cannot map to two values. Okay. We're in the clear there. And based off this implementation, that wouldn't happen. But basically, maybe I'm overthinking this, but there has to be, at this point, like, do I code this up and then try to figure out how to get the keys corresponding to those values later? Is there maybe there's a more optimal hold up. What am I trying to do? By the way, I'm going to exceed the 30-minute timer. I'm so sorry. But I think I'm cooking here. So yeah, maybe there's a more optimal like key value configuration here such that I can also store. So this sounds like a stupid option because my key already has that information, but I could also like make a tuple where I have the values, the frequency, and then the other value is like the key that map to it. That makes no sense though. That feels wildly inefficient, vastly inefficient. Okay. At this point, I can't really come up with a way to solve the problem. So I'm going to pray that I'm going to code what I have so far and that the answer will materialize. It will not feign to materialize, but it will actually materialize in front of my eyes live. Okay. So first thing I'm going to need is my little hash map, which is just a dictionary in Python, which you make like that. How to sort the keys in descending order, return the first k elements. So I make my hash map and I have to create it, right? So for each num, your standard for loop here, for each num and nums And then we index into that hash map. I don't know why exactly or what the if condition is, but I know I'm going to need to write this. Do some plus equals we can do 1 plus, and then I remember LeCode talked about this, the get function, where you can do, I'm not sure if I'm using it right. Let me look it up. Get Python dictionary function. Okay. Guys, we got to know it all in the chat. I'm just kidding. Most optimal solution for the problem is O of n. That's awesome. I'm not even close to touching that. So I just want to, I'm gonna just see this one through. Or should I, because I was feeling that pressure for the time, but honestly, my energy's high. So maybe I should just really think about it. I'm at a crossroads here. I'm at a Judicial Drive, La Jolla crossroads right here. It's a niche reference. Methinks okay, well, an O of n solution would imply that all I do is iterate through the, oh, yeah, I'm cooked. I don't remember how to implement a heap off the top of my head. Damn. Bucket sort. Yeah, I don't know how to do bucket sort. So at this point, I could learn how to do bucket sort or implement this slower solution. But honestly, it seems really tedious. I don't, call me lazy, that's fine. But I don't see a point in doing this if it's not the fastest one. And yeah, there was no way I was going to come up with the fastest one because I just don't know the algorithm. So I think, in the beginning when I'm starting off with LeCode, I need to give up faster because there's so many tools I just don't have in the toolbox yet. And I feel like it'd kind of be a waste of time to try to solve a problem without having all the, knowledge available to me. I guess that's why you study DSA before you start doing this, but oh well. Okay, we're just gonna do a watch along now. Solve this for me. What's LeCode's real name? I want to know. LeCode real name and IP address. Dox him. Okay. Who is? Oh, Navdeep Singh. Nav. Did I do all the array hash map easies? No, I haven't. I was just like, how was I doing this? Wait, did I? Nah. Wow, you're going crazy there. Yeah, I did all the easies, so the rest are mediums. So I kind of just gotta struggle with the mediums now. But damn, bro's nav. Wait, bro, LeCode both codes and raps. That is insane. He does it all. Oh, what's this song? It's like one word. It's one word on repeat. It starts with a T. Mr. Killer Babies, you got it? Thank you. Tap. Damn it. Tap. That's like the only song I like. Okay. Yeah. So we're just going to watch this video. Oh, or I guess I could. I could also like go on a website and learn what bucket sort is. I think I'm gonna do that. And then see if I can apply it to this problem. Bucket sort. How I do that is a sorting technique that involves dividing elements into various groups or buckets. Sure. These buckets are formed by uniformly distributing the elements. Once the elements are divided into buckets, they can be sorted using any other sorting algorithm. Finally, the sorted elements are gathered together in an ordered fashion. We are gathered here today to be sorted in an ordered fashion. Okay. Create n empty buckets or list, damn, and do the following for every array element. So you insert the array into the bucket at index number of buckets times. Whoa, what the hell is going on here? Yeah, maybe I should look at this example because this is a little something crazy right now. How does this bucket sort work? To apply it, okay, sure. We follow these steps. Create an array of size 10 where each slot represents a bucket. Sure. Because we have 10 inputs. How many buckets do we make? I'm assuming n is just our input size. So we make, wait. Actually, not sure. This is a little vague here. Sure, make n buckets. Okay. Create an array of size 10 where each slot represents a bucket. Okay. 0, 1, 2, 3. Sure, I have 10 buckets now. Insert elements into the buckets from the input array based on their range. Ah, man, there's going to be some threshold foolery going on here. Inserting elements into the buckets. Take each element, multiply the element by the size of the bucket array, 10. For example, 2.3 times 10 equals 2.3. Convert the result to an integer, which gives us the bucket index. Is this not like hashing, kind of? In this case, 2.3 is converted. Oh, so we round down, or we round. Sure, we round to the nearest integer, only because here our numbers are decimals. I'm assuming. Convert the result. Okay. Insert the element into the bucket corresponding to the calculated index. Repeat these steps for all the elements. Okay, so enhance. There. Freeze frame. Okay. What was the example they used? They used 0.23. They said it turned into 2, and we inserted it here. What? Okay, maybe I have to keep reading. This still doesn't make sense. Sort the elements within each bucket. And this should be this is step 2. How does step 2? How am I already lost? That's step 2. Oh, there's 0.23. Oh, okay, that's how the bucket works. Right. So each bucket is a list, and then the first element in bucket at index 2 is 0.26, 0.21, and the last one is 0.23. Does it talk about sorting at any point here? Not necessarily. So the only reason why 0.26 is first here is because it came first in the input array. Although somehow it seems to have already sorted everything in descending order, which is what I wanted. Remember, guys? Defending. Is that the magic? How maybe it's this multiplication, that the multiplication and rounding that allows it to automatically sort in ascending order, descending for each bucket. Anyways, okay. Step 3, sort the elements within each bucket. In this example, we use quick sort, which I actually haven't learned yet. I need to learn that. But for now, I know I can use python.sort. Actually, I think I just need to review my sorting algorithms before I do more LeCode, because probably going to need to know that. But python.sort, goated. Okay. The elements within each bucket. Sorting right. Apply a stable sorting algorithm. Why is my scroll like so slow? To sort the elements within each bucket. The elements within each bucket are now sorted. Or I guess now they sorted into ascending order. So maybe these were already in descending for no particular reason. Okay. Let me unzoom because it's not letting me scroll correctly. Step 4, gather the elements from each bucket and put them back into the original array. Whoa. This diagram a little crazy, but iterate through each bucket in order. Insert each individual element from the bucket into the original array. Oh, I see. So then you just iterate through each bucket. 1, 2. Oh, you just go down. You literally go down this list of buckets, and then from left to right, you insert into the original array. So you don't even have to make another array other than the one you made for the buckets and the ones you put. So I guess this is O of n because why? I'm not sure yet, but I already know that the space I'm using is a good amount. Maybe. Okay. But this part probably saves space. The fact that I put it back into the original one. Or not probably, it definitely does. Once an element is copied, it is removed from the bucket. Sure, repeat this process until all buckets until all elements have been gathered. Step 5, the original array now contains the sorted elements. Right. Oh, that's cool. Now I can see the implementation for it. Now, I guess maybe this should be pretty obvious to me now, but I am still O of n plus n is still O of n. True. I do need to remember that. Drop the constant. Okay. So this bucket sort, what would I be input? Well, I guess I'd be inputting nums, right? Oh, O of n plus O plus n is still O of n. I see. So I think I still need to make my dictionary, but for sure, or something. All right, I'm gonna just go with it. I think I still need to make my dictionary, but then the values, no. Whoa, wait, but this leaves me with my same issue. Well, like, what am I sorting in the bucket sort? Am I sorting the frequencies or the actual numbers that those frequencies correspond to? That is a great question. I'm assuming if I'm using bucket sort, then, and I want to return the actual numbers the frequencies correspond to, I'm going to want to sort the actual numbers. But how exactly the frequencies come into play then? Okay, let me think about what it means to be in a bucket then. Here, the purpose of these buckets is just to sort the array in ascending order, in some order. But orderings are like a general concept. And what I'm thinking is theoretically, I can have any like type of ordering I want, right? If I wanted this to be ascending, then what would I do? Maybe I'd make some sort of different multiplication here, or maybe I'd just go through the bucket arrays in the reverse order. But I think maybe these bucket numbers should correspond to the frequencies that I see for each. Goodbye, Mr. Killer Babies. Thank you for watching. Maybe the bucket numbers should correspond to the frequencies of each individual number that I see. Is that why this matters? No, that actually doesn't have to do with. Oh yeah, no, that has nothing to do with it. So somehow I need to insert into these buckets where one, for example, would correspond to the first most frequent element that I see. And then two, or element or elements that I see. Two would correspond to the second most frequent element or elements that I see. So somehow I need to create that bucket structure, but I'm not necessarily sure how. Honestly, I'm kind of proud of. I'm happy enough with the amount of. I think I've reached the point where I just need to know. Because I mean, implementing the algorithm seems fairly straightforward. I've gotten a handle on what I want the ordering to be, which implies that I need to know what each bucket represents. And I've decided that each bucket should represent frequency, where the first bucket is the most frequent, would contain the most frequent elements. But how to actually do that, I'm not sure yet. So I think with this thinking in mind, I'm now going to watch the solution. Womp womp. I love his video explanations. I don't even know if I'm sharing tab audio. Let me make sure I am. Oh my god. Okay. Window, Brave. Oh, to share audio, share a tab or a screen instead. So I have to share a literal tab. It's fine. Or I could share my whole screen. That's cool too. Oh no. I'm not sure if I press share. Noob, streaming noob. Okay, screen 2. Cool. Now we can watch this together. Watch along.
Hey everyone.
Hopefully it's not super loud.
Welcome back, and let's write some more neat code today. So today let's solve top.
Thanks, Navdeep Singh. Appreciate it.
k frequent elements. I really like this problem because it's pretty clever, and once you figure it out, the code is really easy to write. So we're given an input
One day I'm gonna say that I really like this problem. I can't wait.
array nums and an integer k, and we want to return the k most frequent elements that appear in the array nums. We can return the answer in any order. So for example, we have this input array, 3 ones, 2 twos, and a single 3, and we want to return the 2 most frequent elements, right? So we know that the most frequent is, of course, 1. It appears 3 times, so we add a 1 to the output. The second most frequent is 2, so then we add a 2 to the output, and that's all we want. Now, if k was 3, of course,
This is turned into reaction content. I'm like Maze. Was that his name? Jinx Maze? I don't know.
we'd add the last element. K is never going to be greater than the distinct number of elements in the input array, so that's good for us. And our input array is always going to be non-empty. So for example, for each value, right, we're going to count how many occurrences it has. So for example, 1 occurs 3 times, 2 occurs twice, and 3 occurs once. And then we can take this, basically this list of pairs, right? Then we can sort it in ascending
Okay, 1 occurs 3 times, 2 occurs twice, 3 occurs once. Sure.
order, right? So
Sorted in ascending order. I had gotten to that point.
basically,
right?
it's already sorted in ascending order, right? Because the most frequent is here, the second most frequent is here, the third most frequent is here, right? Now, of course, sorting it in the worst case, right? Basically, if every single value in here was distinct and we wanted the top k distinct values, we'd get a time complexity of n log n, right? But we don't necessarily need to sort the entire thing because we only want the top k frequent elements. So in another solution, we could actually use a max heap. So we would still do this whole operation where we count the
Oh, those are so right. The data structure I need is a max heap. The sorting algorithm I need is a bucket sort. Let me look up max heap so I can, before he starts using it, I can have some sort of idea of how it works. Max heap. Shout out Geeks for Geeks. I'm sure I could also use throw some ChatGPT explanations in there. Okay. The heap data structure is a type of binary tree that is right. Okay. Oh, it's just like a priority queue. That makes sense. Oh, it's also what you use in Dijkstra's, which I've implemented, but I don't remember again. Okay, max heap. Oh, there's a heapify in Python. Good to know. Oh, so literally I could just, wow. So I wouldn't have to actually do the whole algorithm. I could. Oh, a max heap is a C++. Oh, wait. Priority queue, which I know how to use. So I could just think of it as a priority queue. That makes sense to me. That means, what is that? 5 first? Last in, first out. All right, there's no, actually, my bad. That's just queue and stack. This is based on the, whichever element has the highest priority is the first to come out. And I think that means that goes to the front of the heap. Anyways, okay, let's keep reading. Any pictures? Here's a picture. So basically, the max heap, right? Every child. Okay, how would I say this in words? So for sure, every parent node has to be greater than its child and all of its child's ancestors, right? Like 15 has to be greater than its children, 5 and 10, and all of the 5 and 10's, not ancestors, all of its children's children too. And it has to be greater than 2, 4, 3. So yeah. Okay. A max heap is typically represented as an array. The root element will be at array 0 for any ith node. Array I, left child is stored at index 2i plus 1. Right child is stored at index 2i plus 2. Oh. Yeah, I forgot about this, man. I definitely did. Oh, that's the bubbling up thing. So this is how you heapify. Oh, right, because and the reason why we're using this index math is because we're representing this tree structure in an array. So let me think of this again. For any ith node, for example, the 6th node's left child is at place 13 in the array. Its right child is at 14, and its parent is at 5. The floor of 5 divided by 2, 2.5. The floor is 2, so it's at the second one. I guess let me talk to ChatGPT a bit. I was trying to come up with a funny line, but ChatGPT's lines were somehow worse than what I ended up going with for the intro. Okay. Let's do some prompting. Explain. Okay. Actually, I understand the concept of a max heap. And I understand conceptually in an array, there's okay. Let's just do this. Explain a max heap like you were in simple, understandable terms. Okay, important to note, it is binary, so each node can only have 2 children. That's how you phrase it. Each parent node is greater than or equal to, or equal to. It's good to know. Each parent node is greater than or equal to its child nodes. Cool. This property ensures that the largest element is always at the root of the tree, which is the topmost node. 1 second. I need to use the restroom. Get smart while I'm gone. Read this. And we're back. Okay. I'm gonna keep reading this. Man, ChatGPT is so helpful. I don't know why I got this negative stigma of it. I think I need to start using it more again. Okay. Right. It starts with one node at the top and branches. Right. Okay. Max heap property. The value of each parent node is greater than or equal to the values of its children, making the largest value set at the root. That all makes sense. Sure. 50 is the largest number, so it's at the root. 30, 20. Same rule applies to every other node. Parents are always larger than their children. Key points, insertion. It's placed at the next available position and then bubbled up if the new element is larger than its parent until the max heap property is restored. So you keep on swapping it with the parent until you now have a max heap. Okay. Oh man, I wonder if, oh no, I'm thinking of AVL rotations. It's something completely different. Okay. Wow, I think I'm overcomplicating this. I remember there's this other structure called AVL trees where when you bubble something up, there's so many different kinds of situations. Like, depending on the structure of the tree, you just need to do a more complicated insertion. But I think in this case, bubbling up, literally just all you have to do is swap with the parent, and that's it. And eventually, your max heap will be. Oh, actually, no, it's a little more complicated. Sure. Deletion of the maximum element. To remove the maximum element, you replace it with the last element in the heap and then bubble down. Swap it with its largest child until the max heap property is restored. Use case. Max heaps are great for implementing priority queues where you need to efficiently access and remove the largest element. Okay. Now I know what a max heap is. Again. Okay. How to do an array rotation max heap. And then I want to know why. Yeah, why is it this? Yeah, why are these the equations, I guess? I could just memorize this. Holy crap, I did not ask it for all this code. Dude, stop. Why do these index equations work for storing a tree structure? Again, definitely learned all of this stuff in school, but I forgot all of it, so time to learn again. Right, okay. I guess it's just something I kind of have to know. That, yeah. Yeah, okay. I don't know why I'm like dying to know the exact reasoning and invention of why this works. And I'm sure it's fairly simple, but I think I should probably just memorize, like, I wonder if this is for all trees. I'm pretty sure. Yeah, for representing a binary tree using an array, you always do, okay. For node I, its parent is at I minus 1, and then divide that by 2 and then floor it. And then its left child is always at 2 times I plus 1, and its right child is always at 2 times I plus 2. Okay, so that's definitely just going to be something I'm going to have to, yeah, just commit to memory. Even though I would love to understand it, I can learn that another time. Where were we? Oh, I mean, I guess. Yeah, and I don't have to, in Python at least, like create a heap from scratch And I don't think, not even I don't think, I know an interviewer wouldn't make me do that because that's not the point of this problem. I just need to understand what what a max heap is and how I can use it, because once I'm in Python, I can just do, where is it? Heap, like make just apply heapify to a list. Okay. That makes things simpler. So where does that leave us? I know I can have, so heap combined with bucket sort. What happens when you heap? Still not completely sure, so I'm gonna just keep watching the video. At least now I get max heap. Okay.
A max heap. So we would still do this whole operation where we count the number of occurrences of each value, and then we'd add each pair to our max heap. And
The pairs are going into the max heap, not just individual values. That's another like conceptual level thing that I keep on forgetting, that you don't have to store single values into these data structures. You can store pairs, tuples, lists, like crazy combinations of stuff. And that makes your solutions more efficient, probably. Yeah, and that makes sense because in a problem like this where, you have elements and those elements have another attribute to them. If like in the dictionary method I was working with, like, what was I going to have to store a tuple in the value, even though I needed the key to be that same value that I would store with the, like, that seems wildly inefficient, which is why we're using a heap instead, and we're just dropping in pairs. Okay, that's long-winded. What I'm trying to, like, big picture extrapolate here is that if I'm ever in a situation where I'm like, oh, just make a dictionary, but then I want to get the keys from my values instead of my values from my keys, then that means I should probably not use a dictionary. Okay.
the key of this max heap would, of course, be the number of occurrences, right? So the count, right? And then we'd pop.
Wait.
Heap would, of course, be the pair to our max heap. And the key of this max heap would, of course, be the number of occurrences, right? So
What does that mean, key of our max heap? Oh, wait. Oh, wow. Huge realizations right now. So I need to remember the difference between like general data structures like hash map, hash set, max heap, min heap, list, etc. Right? But you can't just associate dictionary to well, you can say that a dictionary in Python lets you implement a hash map, but dictionaries aren't exclusive. I'm assuming, I could be wrong in all this, but I'm assuming that dictionaries aren't exclusively for implementing hash maps, because a dictionary is a list of key value pairs, right? Or is he saying make a list of key value pairs? Let me keep watching. It's a good amount of thinking, though.
count, right? And then we'd pop from our heap exactly k times. So why is this more efficient? Well, we know popping from the heap
So I guess what he's saying is, however you're making the heap, you're storing key value pairs in the heap where your keys are the values. I mean, where your keys are the number of occurrences, and then your values in those key value pairs are the respective number that number of occurrences corresponds to. Okay, sorry. I hope that was confusing, but it makes sense to me.
heap. Well, first of all, when we initialize our heap, we're going to add this entire set, and there's a function called heapify, I think, that can do that in actually linear time, so big O of n time. So that's the good thing. And
It's crazy. Heapify can just work with a set of tuples. Oh, so I guess you probably have to specify like heapify based off the values. I wonder, like, when he writes the code, if he's gonna like heapify a list or a dictionary.
of course, we know we're only going to be popping from the heap k times. Each pop is going to take log n, and we're going to be doing that k times, right? So that's going to be k times log n, right? So that's a little bit better than n log n at
Whoa.
time. So that's the good thing. And of course, we know
Heapify is O of n. Sure, just commit that to memory too. Okay.
we're only going to be popping from the heap k times. Each pop is going to take log n, and
So the construction of a heap takes O of n time.
we're going to be doing that k times, right? So that's going to pop is going to take log n, and linear time, so big O of n time. So that's the good thing. And of course, we know we're only going to be popping from the heap k times. Each pop is going to take log n.
Oh, we're only popping k times. Yeah, and each pop, worst case, is log n. Why? I'm not exactly sure. Does it tell me? Oh no, I know. From a max heap, you're gonna pop the element with the largest priority, right? You remove the maximum element, but that operation in itself of popping takes log n because you essentially need to you replace it with the last element in the heap and then bubble down, swap it with its largest child. So because it's a binary tree structure, right? If you were to bubble, in the worst case, when you're bubbling down a number all the way to the bottom, I'm only going through, at the worst case, log times the input size elements to bubble that element down, which is why the insertion in the worst case takes log n. I mean, popping from the max heap takes log n worst case. Okay. Wow, so much I don't know. It's fine. Keep going.
And we're going to be doing that k times, right? So that's going to be k times log n, right? So that's a little bit better than n log n, at least as long as k is less than n, right? But it turns out that there's actually an even better solution.
Pause.
And we're going to be doing that k times, right?
So the naive solution is to use a max heap and then pop the k pop the k most frequent elements. And he's saying that k
n times. So that's the good thing. And of course, we know we're only going to be popping from the heap k times. Each pop is going to take log n, and we're going to be doing that k times, right? So that's going to be k times log n, right? So that's a little bit better than n log n, at least as long as k is
Right. Okay. I need to remember that too. That if I have multiple variables, in this case, the size of my input, and then another variable that determines like kind of what kind of input I want to have, then a lot of the times that other variable is going to be a part of my what's it called? A part of my time complexity and maybe space complexity calculation. Yeah, I think my current understanding of both of those concepts is still very rigid and not. I think it means I need to more deeply understand the concept so I can apply it to various different situations. But this makes sense, right? Uh, in the worst case, it is n log n. So this is where best, average, worst case comes into play, because if I so and in the specific problem, in the worst case, k log n is n log n, right? But then there's all the other cases which aren't the worst case, in where k log n is going to be faster. So uh, yeah, so instead of scaling with input size, I'm scaling with like whatever you want to call k, which is an important distinction to understand. Right, and like I was saying, for all the cases where k is smaller than n, which can happen a lot, k log n is faster, which is uh, impressive, I guess. And I think when I'm reading this problem, like what should have told me that I wanted to use a max heap. I think, at least for this implementation, I guess the signifier should have been like the word frequent, right? Whenever I'm dealing with frequency, most frequent, return most frequent elements. That means, and in my brain, it makes sense just because I've dealt with priority queue, the word priority queue way more. It makes sense to think of max heap as priority queue. So uh, that frequency thing, return most frequent things, should have raised alarms in my head and been like, okay, if these integers have if there's a certain priority that can be priority level that can be assigned to each of the elements in the list, then I want to use a max heap / priority queue. That is to say, the ordering are the elements that I want to return have an ordering, and the ordering is frequency, not necessarily ascending or descending. Should I try to implement it with a max heap? I'm going to try that. Even though max heap isn't the fastest solution in this case, I'm sure there will be situations where it will be the fastest solution, and I should just get used to it. Hold up. I'm going to submit this and then clear everything. Just because so I can save it in my submissions. Perfect. And then I'm going to clear everything. Start from here. So in order to use a max heap again, I went on a whole like exploratory thing. Max heap solution. I'm going to want to what the chat, my diploma arrived. Now we will say congratulations. Okay. All right, to use a max heap, I'm going to want to, the underlying structure for this max heap is going to be a list, right? So I'm going to call it m heap. It's going to equal a list. And what I'm inserting into this list are key value pairs. So Python How to make key value pairs. So I guess I'm gonna have a list of dictionaries, right? Because every element in my list needs to be a key value pair. And the only way to do that is with the braces notation. So for num in nums, we're going to say insert nums. We're going to insert into the M heap append what are we going to append? I think we can just like raw and put a key value pair like this, where our key is going to be the frequency, right? So the frequency of the occurrence, which is going to be a variable that's going to be incremented by 1. So maybe I should just make it like this. Frequency. Yeah, I can just do colon. Cool. Okay, colon. Colon frequency, and then the value is going to be the actual number that frequency corresponds to. And then to calculate the frequency, I'm going to want to do, we're going to initialize frequency as 0 here. And then if, how would I do that? Oh no, at this point it's fine now. Freak equals 0, and then I think we could do like freak plus equals 1. What? Could I do that here? Wait, something is amiss. My mind is running amok. I'm being led astray, bamboozled, flat out deceived. Something ain't right. And that would be that I only have one more stick of gum left. Why is this giving me trouble? Okay, if I think of, wait, this implies that my keys would be changing. If I just use a regular pair, like use a tuple function, would that be better? Let me look this up. Can you change? Yeah, It doesn't make sense to use key value pairs because the whole point of key value pairs is that you don't change the key once it's been assigned to a value. So I could make a new key and then update the name and then blah, 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 blah. But I think what I'm going to do instead is just make a pair of values where, okay, so frequency is going to start off as 0 for each number. Or maybe I should do the if first. Maybe that'll make more sense in my head. If the number is already in, no, damn, see, because to do this check, I need to understand what the pair structure looks like. Okay, I know I want to do this. Num freak pair. Use tuple, and I want to use the frequency, and then I want to use num, right? And then here's what I want to update my frequency. If num in M heap because I'm inserting pairs into the heap, the max heap. But then I can't just use this in thing. I see what's going on. I need to build this key value pair thing first before I even try to make a heap. That's the issue. Yeah, I don't know why I was trying to do it at once. That doesn't make sense. So now, okay, all I need to do is focus on make frequency num pairs. And I should just store this in the list too. Damn, man, this is tough. Why is this so hard for me to understand? Do I need another list? I feel like I might need another list just for the values. The values are the individual numbers, right? Yeah. Or like the actual elements themselves. Yeah, like key value kind of thing here. So I feel like I might need another list just to place the individual numbers, and then I can check if it's in that list already. So num list. If num in num list, so if we already saw this element once, then let's just do this. Let's say not in. Then we can say frequency equals 0. Right. Frequency equals 0, and then num frequency pair is equal to tuple frequency num, and then just append this to, we can append numlist dot append num. So now we know we've seen it, and then I'm actually going to make this a set, because all I need to do is see if it exists in there. So that should be now O of 1 lookup theoretically. And we don't, do you append to a set? You add to a set. And then I want to append this pair I made to the M heap, to the max heap. So I'm gonna call it max, because M also could be min. Okay. Max heap dot append num freak pair. Okay. And then I can just move on to the next number. Otherwise, when I make this, my frequency is going to be, I'm actually going to append plus equals 1. Wonder if it'll just do that math for me. Oh, but it doesn't know what the frequency is yet. Oh no. Well, see, man, this is why I'm not sure about Python and stuff, because in like C++, I'd have to at the very least declare this somewhere out, like outside of everything, because the compiler wouldn't know what it is. But I think in this case, if it does exist, it'll just know what it is. Or maybe it won't. We'll find out when we... Actually, I can just compile it right now. Yeah. So that's just, I just can't do that. Can I just do, I don't know why I'm doing plus, no. Yeah, I have to do this in another variable. So frequency equals the old frequency. Oh, I have to get the old frequency. Right. And I can assume the old frequency is in my max heap. But then how the hell do I know where it is? Damn. That's why it would make sense to add key value pairs. Yeah, how do I know how to get my old frequency? Well, max heap is full of pairs. So I could find I'd have to find the pair. Yikes. I'm gonna have to, man, it's got me stumped. How am I going to find the pair? Like, I could do a search, but that can't be the way to do this. index into or look for the num. I have to find the num in my max heap. The current number where I have to find it in my max heap. The only way I can think of doing that is at best a binary search. Yeah, so I don't know how to make that K login like he was saying. So maybe I'm just doing this implementation completely incorrectly. Should I ask ChatGPT? I think I will. I think I am. Because I think there's a core issue I'm not understanding about how to solve this using a max heap, and LeCode's not going to go through it because he, if I'm not mistaken, he I think is only doing the most efficient solution. Yeah. And I want to learn how to use a max heap too. So let's see what it gives us. Really? Counter is insane. This is an insane solution. I could get this, right? Get the top K most elements, but I couldn't even do this part. Or I could. What does counter return? It creates a dictionary object where the keys are elements and the values are their respective frequencies. So it's not using the key value mapping that LeCode was talking about. Oh, but that's why O of n plus n is still O of n, right? So I'm heapifying. Yeah, but I still have to do this next iteration. Another iteration, which is what I was trying to avoid in my code. But it seems like there's not really a way around it, you know? Oh, my brain's getting fried. Oof. Keep going, we must. All this is doing is what? What does dot items do? So this makes it into a heap. This creates the dictionary-like object. This part inserts the elements into the array before I do the heap. Okay, what I'm going to try to do. Damn. I want to tap out so bad. Got to keep going. Okay, I'm not going to use frequency number pairs. I'm going to use number frequency pairs. I just don't know how to do it with, I don't know how to do it like the other way around, unfortunately. Keys are elements from the array and values are their respective frequencies. Okay, I want to see if this works first, actually. And then I'm going to do like my own version of it after. Yeah. I'm assuming ChatGPT would be pretty good at this kind of stuff. Okay, don't give me the check yet. I copy pasted from ChatGPT. Okay. So I don't want to use counter. Now I know I can use it, but I'm just trying to do it the way I was doing it before. So to do it the way I was doing before, I would be inserting key value pairs here. This is going to be num. This is going to be the frequency. Now I don't need this stupid thing because I'm doing it the other way around. And I can just say if num is not a key in max heap. Yeah. I guess if this is storing key value pairs, doesn't that make it a dictionary? I don't want to look at the answer code again. I need a dictionary-like object. I just, unfortunately, I do need it. So I'm just going to store it in a dictionary. Right. We're going to index, so our key is going to be the number, Our value is going to be the frequency we calculated. Or in this case, if it's not in frequencies. Yeah, I'm trying to do too many things at once. Then we continue. Otherwise, all we do is do this. Oh, crap. You get the original frequency, and then you add one to it. If we haven't seen it yet. Yeah. That makes sense. And I guess to avoid this whole if-else thing, I could just do it's called .get. I don't know which is better. We'll try .get. We'll just get used to that. LeCoding knows more than me, right? So this should get the value. So it'll make a key value pair where the key is the number and then the value is equal to either 0. This will return 0. Let me see. Get value method key Python. Yeah. Okay. So it either return 0 and the frequency of the number is 0, or it'll do I still have to check if it's there? I need to remember I'm creating the frequency for the first time. Yeah. I'm creating the key value pair in the dictionary for the first time. So how do I avoid doing a +1 here? I kind of have to. Oh, no, that's fine. I'm stupid. Wow, I'm losing it. I have to stretch in a bit, but because if we're iterating through nums, that means we saw the number, right? So either our first insertion of the key value pair into the frequencies dictionary is going to have a value of 1, or it's going to have a value of a number greater than 1, which implies we've seen the number before. And then this +1 basically will increment the amount of times we've seen it before by 1 every time we see it again. That makes sense. That's fine. Now we've made this is basically what counter does, I'm assuming, right? Yeah. Counter just does this. This needs to be a comma. This needs to be a comma, and I need it stretch. So let's maybe even take a break. Okay. I am taking a 10-minute break, or 5-minute. See if I can grab something to eat, put in my mouth. Why? Because I can, and I've been here for 2 hours. Okay, BRB. Okay. I'm going to try to knock this out now. Okay. Cat is crying in the background. Poor guy. Poor guy. Right. I made my frequencies, which is basically what counter does. Cool. Now I need to make my max heap. So all I need to do that is insert each dictionary pair into the max heap. Right? Maybe I have to use list comprehension for that. Okay. Now max heap is gonna be an array, and then I need to insert every pair into this array. I'm just gonna look that up. Yeah, use Google. It's fine. How to insert dictionary elements into array Python. And then I guess heap if I can work with those elements. Huh. It does have to be list comprehension, unfortunately. Fortunately? Who knows? Who knows? Okay. Damn. Okay. So let me look up how list comprehension works. As output expression, input sequence, x is a variable, is the predicate. How do I read this? I just need to figure out the English. Oh. For x in range 1 through 11, if x mod 2 is equal to 1, append x to the second power, I guess, or times 2. I don't know what 2 asterisks do. Oh, I see. It's just a shortened form of this, which is what I would have to do. Maybe I might not need it if. To insert into this max heap, I could do so. Each element in the list I want to be the num, because eventually I want to output my actual elements, right? Yeah. Eventually I want to output my actual elements. So my output is going to look like, I could just do the input sequence part. For num, man, yeah. For each number, for each pair in frequencies, I want every element in this list to be the number. How to get the key? How do I get the key? I want to get the key. Wait, I wonder what this will do if run at all. It won't do anything. Give me each pair. Yeah, so this list comprehension thing is very new to me. I don't understand it yet. Really? What is wrong? For none type and I thought the whole point of get was that. Oh, you do comma 0. Okay. That makes a lot more sense. That's fine. My bad. Print max heap. I can't even see my error. What? Oh my god. Oh, I did get output. 1, 2, and 3. Oh, wait. Why is it only giving me 1? Oh, this is going through the keys then. Yeah. This is going through the keys. And I want to sort based off value. This part, this input sequence for X in sorry, I'm talking a lot less. I'm a lot tired now. I'm kind of frustrated, but I want to get this down. I wonder if I could iterate through the keys and the values at the same time. Does that make any sense at all? Probably not. Oh, crap. Yeah, there's not even standard. Huh. Let me think about this. I'm gonna have to look back at the ChatGPT solution, unfortunately. It's so frustrating. All I had to do was use items. Damn, bro. Okay. Right, that makes so much sense. And then what I assume this part is doing is it's turning it into just kind of a pair that's not a dictionary object anymore. And then this is where it reverses. Reverses in the sense of, yeah, I don't know what these parentheses are doing in this context. Creates a list of tuples where the first element is the negative frequency. If it's a list of tuples, oh crap. How is Heapify working on the first or second tuple? Oh wow. Man, that's complex, bro. Yeah, it definitely is. Yeah, so essentially I'm turning it into a tuple, and again, this has to be negative in order for it to be a max heap, because by default heapify will heapify it in terms of where the parent always has to be smaller than the child. And I'm heapifying based off the frequencies, even though each element I'm inserting is a pair, right? So it's heapifying off the frequency, and once all my pairs, all my tuples are heapified in the tree structure in the array, then I can get a specific pair I want and then use brackets 0 or 1 to get the number. In this case, I'm going to want to get the number, right? So I'm going to want to get 1. So a huge thing I didn't understand here, I think, was that, one, when making the array, I can switch the order of my pairs. Two, I can turn dictionary pairs into tuples by just doing this kind of list comprehension style thing, right? Three, I can switch the order of those key value pairs when I'm making that list out of the dictionary, which I had no idea you could even do. Makes sense, but like kind of blows my mind. So how would this look if I were to do it in like a regular for loop fashion? Would it be like this? For each item and number and frequency, I would max heap dot append the negative of that frequency to make it a max heap and the number. So the reason why the negation works here is um, obviously a larger positive number is larger than a smaller, like the value of a positive number, but a larger negative number is actually smaller than a smaller negative number, right? So that's why heapifying it with the negation will give me the same behavior, essentially. So this is just equal to this. I'm going to keep this here in the comments, I remember. That makes a lot of sense. This makes sense too now. So another technology, I mean, I don't know why I was so reluctant to learn something like list comprehension. That seems to be a pretty basic operation in Python. It's something I should probably get used to too. Yeah, cool. I guess here's I need to think that like there's no issue with using this, even though to me maybe it's not fancy, but to me it seems like kind of like fancy advanced, like squishing a lot of notation into one line thing. Uh, I don't see a harm in doing that unless, and I think I should strive to do that unless it's less readable, or two, I'm asked to just not do it that way. And I should know how to do it. I should know what Python is structurally doing, right? That I should know that this list comprehension directive is just equivalent to this for loop. So if asked to, I can do it both ways. But to be honest, this is fairly readable, right? Like once you understand the syntax, which took me not that long, it would take someone that's a much better programmer even less time, then this also becomes readable. So all that to say is, I see. Now that I have my max heap, all I want to do is return the k elements, be like my return array. And I'm just going to iterate through for every num. Oh, okay. First thing I have to do is heapify this, right? So max heap dot or heapify max heap, and then yeah, for each num in for each pair in max heap, I want to k elements dot append. And what do I want to append? I want to append the number portion of the tuple. So that's, even though we heapified based off the negative frequency, I actually want to return the numbers, which is easy. All I need to do is pair 1, and 0 would give me the frequency. And then all I need to do from here is just return k elements. And then this should work. I'm not even going to, well, actually, I'm not sure of this notation, so let's find out. Yeah. How do I call heapify? Damn it. Heapify iterable. You have to call it on. Oh, I need to import heap queue. Is that true? Seems like it. I do. Okay. Hold up. Import sys. Hold on. What does ChatGPT say again? How did it do heapify? Oh, I need heap queue. Yeah. Okay. Again, this is a little slightly annoying to get used to, I guess. Like the way we call functions on objects in Python. Because like it doesn't make sense. To me, it's very weird that this saves the output to max heap. Like I would like to do max heap equals something. Yeah, anyways. Interesting. What am I doing wrong here? Oh. This only needs to run k times. So for each pair in max heap, how do I specify a range in for each loop? Yeah, I know I use range, but I want to iterate through something and use a range. That's amazing. Okay. And I only want this to run k times. Can I add an if here? Is that insane? How did... Oh, man. Now I feel like I'm cheating, but I'm learning still. That's annoying. Okay, I don't have to do it the way they did it. I can just make a counter, which is fine. Yeah, I'm gonna just do it this way, even though I could do it a little fancy way. Okay. Oh, I can't use K. I have to use counter. Counter equals K. Then return K elements. Honestly, I like using a counter. Some people might not actually, but it just makes sense in my brain. And then counter plus equals 1. And yeah, now this should work for case 1 as well. Oh, bro. Wait, what? That is interesting. Oh. There should only be 2 pairs here. 1 pair, actually. And it's that it should be 7, 2. Okay, counter 0. But we want K to be 1. We append 2. And then counter equals 1. And then counter equals 1 and we return nothing. So what is the issue about this? How am I returning nothing here? K is not equal to 1. That is really interesting. Let's figure out why that is the case. Print max heap. I should return 7. So this should look at -2, 7. Counter is 0. Counter and K is 1. So I don't return. Otherwise, I append 7, increment my counter. What happens if I print K? So why the hell am I outputting nothing? That's insane. Seven. What in the... This is crazy. Look, K elements is literally... What? I dropped the print statement and we died? Why? What issue does it have with counter? If that's a variable, what? Okay, print's -2, 7. 1 is K, counter is 0. K elements is 7. There's only one pair in the max heap. God damn it. That's why this isn't working. So here's how I fix this. So what's happening here is that how do I phrase this? Basically, my function, there are obviously in several situations where there's going to be less pairs. Turn on my lights. All of the lights. What are they saying? Okay. Damn, that's bright. Turn that whole around. Okay. Obviously, there's going to be a bajillion situations where there are less pairs in my max heap than there are. Okay, each pair represents a unique element. So although I can have more unique elements than I want to return, at minimum, I have to have an equal amount of unique elements than those unique elements that I want to return. So if those two numbers are equal in my current code, so basically I have one, in the case where I had one unique element, I was immediately returning Counter equals K. Let me think about this. Okay, I know this is going to work. I'm having trouble explaining why, though. Bro, this is crazy. Now I put it 3 and 1. 1, 2, 1, 1, 1. I mean, did we just forget about 5? But then why does the ChatGPT code work? What are we doing differently here? So pop from the max heap, the first element from the max heap. Oh, I see what I'm doing wrong. I'm never... This type of iteration, it doesn't guarantee that I pop the biggest element. Or, okay, I need to pop in the order of the heap. Just iterating like this isn't iterating in the order of the heap. It's not... It isn't because the array used to represent the max heap structure isn't linear. As you know, we have the 2i plus 1, 2i plus 2, left to right child, and the parent is at I plus 1 divided by 2 floor. So yeah, it's not contiguous, that is to say. Because it's not contiguous, I can't iterate it like I would any regular array, which is why I need to use pop. So in reality, what I need to do is damn, unfortunately, I have to pop in a loop. I have to pop k times in a loop, which is exactly what the ChatGPT code does. So that is what I have to do. Yeah. Oh, whoa. Yeah. Man, I'm tired. I have to pop in a loop. Okay. So for pair in, and I have to pop k times. I want to... Damn, that was an important lesson, I guess. I want to append to k elements from heap q, call heap pop, and then heap pop from max heap. Not sure if I did this notation right. We'll find out. Holy, oh crap. And give me the number value, actually. Hit submit. Holy crap. Again, man, this is frustrating. Oh, I put this in the wrong spot. Pop the tuple. Now I have a tuple object. Then get the number from that tuple object. Okay. Glad I thought about that. Whew. Okay, y'all. This is a k log n solution to top k elements in the list. Fortunately, this isn't the most efficient solution using bucket sort. I'm going to have to do that tomorrow. I'm kind of spent after. Yeah, I'm going to have to start coding in blocks. One 3-hour session a day isn't going to cut it. I'm going to have to maybe do something in the morning, do something in the evening. That way I can just code more, get more problems down, and, really prepare for interviews and stuff. So, yeah. I know this wasn't the most efficient solution. The reason why I opted to implement it in using a max heap is because I have never solved a LeCode problem using a max heap. So I just wanted to see what it was like using a max heap, what it would be like to use a max heap. And I had to learn what a max heap was again. I had to learn what list comprehension was. I had to learn how to call, how to like create a priority queue or max heap in Python. Using kind of like importing the module like you would in C++, and then the notation, creating the heap object from which I can use the pop, insert, delete methods, or whatever methods heap has. So this is kind of like the standard data structures like that exist in C++. But I didn't really know how to do that, I learned this crazy trick where you create a dictionary using the key value pairs in one order, and then store those pairs in a different order when putting it into a list to make it into a max heap, because heapify works with the first number in the tuple when you're storing pairs. Yeah, man, learned a lot. And again, the reason why intuitively one would think max heap to solve this problem is because we want to return elements that have a certain characteristic to them, right? If elements have some sort of characteristic that can be quantified in the sense that there are, for each characteristic of each element, there are characteristic, like that characteristic can be thought of as a number. And then that once you can think of that characteristic as a number, then you can order those numbers right now. Because now that, or what am I trying to say? Once you can think of the characteristic as a number, then that number becomes a priority, or some sort of like quantifiable value in which you can order and in which you can order the elements in your in this case max heap binary tree data structure thing. Oh, so they were looking at me. Yeah. So hopefully I recognize when to use max heap more often now. And just remember, I can just create a max heap by importing this module and then calling heapify on the list. And now I have a heap object. Okay. Catch you guys tomorrow. Okay. See, I'm feeling lazy, but unfortunately the only way I'm gonna get through these things is if I work. So I'm going to, now that I understand the solution, tomorrow I'm going to watch the LeCode bucket sort solution. Then I'm going to try another LeCode problem. Ideally, I'm going to try encode and decode strings. Learn whatever materials I need to learn to do this problem that I don't already know. Who knows how long that's going to take? Could take a while. If there's a more naive solution to it that involves a data structure or an algorithm or both that I haven't used yet, then I'm gonna kind of do what I did today, where I'm gonna solve it in that naive approach, and then solve it using the most efficient approach, just so I can learn in both approaches, right? Because how am I supposed to solve this using the most efficient method if I can't even solve it using the lesser efficient method? But yeah, and then hopefully I can also work on my project tomorrow. I've only been able to like work on a project or do LeCode like one thing a day, but I need to be doing both. So hopefully I can work on my calendar project, because that's almost done. Like I can't believe I just imported a file and then I made all these events. That's pretty sick. But I just need to change a couple more things. That was like regex stuff. Eek. Okay. Randomly got 2 viewers at the end, which is insane. But bye guys. Thanks for coming. See you later.